to learn something new. You're going to learn something new today, because David has written 6 books. He started in Leeds. He was somebody who was very keen on literature. His PhD took him down that road, and then he has studied a whole lot of things. I'm sure he will say the words deep time, and he will say the words future fossils, and he knows what they mean, and hopefully will explain some of them to us. He is willing not only to speak to us, and I'm sure in an entertaining way for those here and those watching at home, he is also willing to stay on and ask questions. To ask a question, if you put your hand up when David gives the opportunity so that I can see who you are, because people are watching from home, I'll bring the microphone so that everybody hears every word. That would be really helpful. But please give David a very warm welcome to Morningside. David, over to you.
Hello, thank you very much for that, Ian. That was a lovely, very generous welcome. Thank you to Derek for inviting me. It's a pleasure to be with you all here this evening. Is my voice coming across well enough? No? Okay. Maybe if I hold this. Is that a bit better? That sounds better. Okay, good. Yeah, I thought I might try your patience early by beginning with a reading, if that's okay. But the book that I'm here to talk about, Nature's Genius, starts with a particular story, a story about a kind of bird that learned to love roads. And this story sets up the whole context for the argument that follows. Throughout the 20th century, the cliff swallows of Capistrano were emblems of constancy. Each spring, the birds would travel thousands of miles from their wintering grounds in Argentina to their nests in the eaves of the Mission San Juan Capistrano in California on exactly the same day each year, the 19th of March. Their return was greeted as confirmation that the cycles of the natural world would revolve forever, unyielding and true. Cliff swallows are a small passerine bird, typically no larger than the span of a human hand. They wear a white triangle on their foreheads and bright rouge on their cheeks over a dark cap and coat. Their wings are long and pointed, but instead of the barn swallow's elegant tuning fork, cliff swallows' tails are as squat and square as shovels. The birds dwell in cliff-face colonies of several thousand, where they build gourd-shaped nests out of mud. Their reputation for fidelity to the calendar does not rule out an ability to adapt where necessary, however. Cliff swallows were originally distributed along the California coast, but the westward expansion of the United States in the 19th century provided opportunities to spread east. Woodland cleared for pasture created fields and ponds with plentiful insects to feed on. And with each new farm and town, there were a host of cliff-like nesting sites in the shape of barns and buildings. In particular, the birds learned to love roads. They followed wherever the highways led, building their pot-bellied nests under bridges and in culverts in colonies of raucous thousands. Ornithologists began studying the social behavior of roadside-dwelling cliff swallows in the 1980s, and as the years passed, they began to notice something strange. Roads are typically very dangerous places for birds, especially since they've come to be dominated by hulking SUVs. But as the cliff swallow population grew, unexpectedly, the numbers killed by cars steadily declined. When the scientists compared the wingspans of road-killed birds with those of the general population, they discovered a curious difference. Road-killed swallows' wings were characteristically long and pointed, but in swallows that had managed to avoid the traffic, they had become short and rounded, trowels rather than stilettos, as we can see in the slide there. This blunter shape made the birds nimbler, better at sudden vertical takeoffs and the knife-edge turns that would take them out of the path of oncoming vehicles. Short-winged swallows, it seemed, were just better at playing chicken. Evolution can have many different causes. A food source may decline or a new one appear. Helpful mutations can bubble up in the gene pool. Populations of different species come together, spurring one another to adapt to competition or threat, or they drift apart to develop in isolation. All living things are in some way a product of the combination of pressure and time. The particular pressure bearing down on cliff swallows' wings came from 3-ton SUVs traveling at high speeds. In just a few decades, these emblems of unchanging nature had evolved, and the reason was us. So that is, I'm going to see if I can attach this in a way that you can still hear me. Okay, how is this better if I project? Okay, that may be better. Just to avoid the chance of feedback, I'll turn that off. Okay, how is that? Is that better? Okay, apologies for that. I won't read it again. I think hopefully you got the gist. That's how Nature's Genius begins. The book really began for me when I came across a startling fact that humans are now the driving force of evolution on our planet. This has been observed for many years now, and many scientific papers are confirming the fact that on every continent, apart from Antarctica, you can observe animals, plants, insects, all kinds of life adapting their bodies and their behaviors to the demands of life on an increasingly human-dominated planet. We tend to think of evolution as something that happens very slowly over deep time, as Ian said, over millions and millions of years. And often it does, but there is always the possibility that change can happen in biological organisms very quickly, startlingly quickly, in the matter of years even. It was this startling fact that really grabbed my attention. How could it be that we are such a dominant, potent force, that we're intervening in this profound process by which life has thrived and changed on our planet for nearly 4 billion years? And the more I became interested in this, the more I began to see the possibility that it might have something to teach us as well about how to live and thrive on a planet that is full of ecological challenges. Now, the first thing I want to say about this, to get what might be a misconception out of the way, is that I don't for a moment believe that the fact that many birds, fish, insects, mammals are adapting and changing is any reason to be complacent. This is not a case whereby nature will simply heal itself. It will fix the problems that it faces, that we can trust the natural world to get on with it, and it will be fine on its own. That's not what I'm talking about here. In many cases, the kinds of adaptations that we're seeing aren't long-term good fits for the world that is coming. Maladaptation is a particular problem here when rapid change happens. That a creature might adapt to a particular pressure in the short term, but then it can't keep up with the pace of environmental change and is left stranded. Other creatures are too closely fitted to their niche to really be able to adapt to a whole new set of pressures. So what we're looking at here is a process where many species are going to kind of wear the imprint, if you like, of human activity, human influence in their bodies, in their genes, in their lineages. But it will be the generalists. It will be the hardiest species. It will be a less colourful, less diverse, less biodiverse planet. And that picture sounds, I think, quite bleak. But alongside that, I believe that there's a great deal we can learn from the tremendous potential we find in nature for doing things differently, that can teach us a great deal about how to do better than we are at present. So I work in the Department of English Literature at Edinburgh University. I love learning new words, and so what I thought I'd do this evening is introduce to you all 9 words or terms that are particularly important in the book that you may not have come across, that I think can help us to think in new ways about nature's genius for transformation. And the first of those terms is plasticity. Now, I began by talking about evolution, and there are instances where it's been demonstrated that new species are diverging from the kind of the original, as it were, that speciation is taking place. But the vast majority of the change that we're seeing isn't quite the emergence of new species. It's what's called plasticity. Every living thing has a degree of plasticity in its genome, in its being. Plasticity essentially means the capacity or the potential to express different genes or to express a different combination of genes in response to new pressures. So what this might mean, for example, in the case of the cliff swallow, is that it became an advantage to have these shorter, blunter wings that made those birds more agile. That created an evolutionary advantage, a kind of an ability to survive in a newly threatening environment. And it was those birds that had that plasticity to develop these shorter wings that thrived. Plasticity, and this is the first key word to kind of hold on to. Plasticity is the secret of nature's genius for transformation. We might think that the kind of forms that any living thing has arrived at in nature is a kind of is the final form. You know, what it means to be a giraffe, what it means to be a daisy, what it means to be a humpback whale. But these are all variations that are expressed at different times. So we need to hold on to this idea of plasticity, that actually the capacity to do things differently in response to environmental pressures, new changes, can be absolutely vital. The second term I wanted to introduce you to is biomimicry. Biomimicry is a word coined by a biologist called Janine Benyus. Essentially, biomimicry means designing things after nature, following the example of how the natural world does things and using that in our own inventions and our technology and so on. A good example of this is the way in which the particular shape, this kind of stippled shape of a humpback whale's flipper with these they're called kind of tubercles. You can see the nodules on the edge there. These create a much more kind of dynamic, aerodynamic, I should say, flow through the water, and it influenced the design of wind turbine blades. An engineer called Frank Fish, ironically enough, kind of, realized that he could make much more efficient wind turbines that would generate much more energy if he borrowed the design of a humpback whale's flipper. The modern world is full of inventions that borrow from nature. The nose of a fighter jet or Velcro. There are countless examples where we can see this. Nature's genius really began for me when I asked myself, what would happen if we put together biomimicry with plasticity? If we're not just thinking about how we design after nature as, it kind of currently exists, but if we design after nature in terms of how it's adapting, if we observe how certain species are changing, is there anything we can learn? I was lucky enough to have a conversation with Janine Benyus early in the writing of this book, and she said something to me that really changed the whole direction of where this was going. It was going to be very much a book about these are all these wonderful new inventions that we can make that will help us address the climate crisis, that will help us address the biodiversity crisis, and they all borrow from nature. And she said to me, though, she's a great believer in biomimicry, but she said, we don't just need a change of technology, we need a change of heart. He said, simply looking to technology to save us is not going to get us anywhere, because it doesn't change the fundamental nature of our relationship with the rest of the living world. And at that point, Nature's Genius became at least as much a book about the plasticity that's in us as it is a book about the plasticity in other species. I don't mean that we need to alter our biology, that we need to change our physical form, but we do need to change our ideas, we need to change the way we live. And I firmly believe that the example of the living world can help us do this. So I'm going to take us, hopefully not too tardily, through 3 different ways in which we might look to nature and how it's adapting to a human planet to make some positive changes ourselves. How we might develop more sustainable cities, how we might rethink our relationship with time, and how we might save species that are threatened with extinction. So the next term is urban evolution. It's one of the more remarkable things that I discovered in writing this book, that our cities, our urban environments, are hotspots for plasticity and speciation. There are more examples of this happening in the places where we live than almost anywhere else. And it's because our cities are, in some ways, ersatz versions of many different natural environments. A tall building is like a cliff face. We have parks that are like forests and savannas, and cellars that are like caves, underground systems that are like cave systems. There's lots of versions of the kind of environment that an animal might wish to live in, might feel is kind of attached to. But also there are very particular conditions in a city. Most obviously, or most prominently, I think, what's called the urban heat island effect, whereby temperatures in cities tend to be 1 or 2 degrees higher than the surrounding environment. And so one example of a change that's an urban evolution in response to this is snails in the Netherlands are developing lighter shells so that they reflect more of that heat back. They don't absorb it into their bodies. Lizards in Los Angeles have been observed with larger scales as well for the same reason. Many of these changes are small, but they're concrete examples of animals and plants changing their bodies or their behaviors to live better, to be better suited to life in the city. And another example is this. This is Crepis sancta, or sometimes known as hawksbeard. It's a plant you'll see in cities across the Northern Hemisphere, including here in Edinburgh. I'm sure you've seen it, possibly even on your way here. It typically will produce 2 different kinds of seeds, a lighter airborne seed and a heavier seed that falls very near the plant. And this allows it's got a kind of dual strategy for kind of propagating itself. But it's been observed that these plants, when they grow in the cities, really don't produce very many of the airborne seeds because it's not a very successful strategy. The seeds get blown away and then they land in concrete. But the heavier ones tend to land in the same soil that the plant is growing in, so they have a much better chance of success. So this whole reproductive strategy the plant has evolved over a great deal of time is changing to make it better fit the city. As I said, there are many of these examples, and in some ways they might look quite minor, but they're evidence that the city is actually a really very potent evolutionary environment. What can we take from this? Well, as I said, some animals and plants adapt themselves, but others, in a quite an exciting way, I think, choose instead to adapt the city to their needs. I'm sure that many of you will have seen anti-bird spikes around Edinburgh. They're these bristling strips of spike, like steel needles on window ledges, on cornices, on top of lampposts and fences and walls. They're designed to keep birds from roosting and perching and nesting on buildings where they might make it look messy. Basically, they're like a kind of hostile architecture for wildlife. However, crows and magpies in Antwerp, Rotterdam, and Glasgow have been observed stripping these spikes away from buildings and using them to make their nests. They're taking something that was designed to exclude them and transforming it into a shelter, into something that will keep them safe and protect them. And there is a term for this, an equivalent term for this in evolutionary biology. That is exaptation. An adaptation, of course, is a characteristic, a feature that emerges in response to a particular pressure. An exaptation is when a whole new use for that original adaptation is discovered. And a good example is the evolution of feathers in the earliest birds and feathered dinosaurs, I guess. Feathers didn't evolve to allow for flight. They evolved as a form of insulation to keep the animal warm. It was a response to a change in temperature, effectively. It was only much later that this form of insulation permitted some birds early birds to glide and then to fly. It was an adaptation to insulate, to keep warm, that was exapted to a wholly new flight, a whole new way of getting around, a whole new kind of mobility. Exaptation, I think, puts the repurposing of what's already there at the heart of evolution. So what if we were to make this the basis of how we design our cities? An exaptive approach could be the key to unlocking the kind of circular economy that I think we hear so much about and that we are so much in need of. A great problem with the way that we engage with materials, and particularly the way in which we imagine and build the kind, the urban environment, is that we only think in terms of one lifetime, if you like, of the object. We never imagine the afterlife. Every single building that has been put up in Edinburgh will at some point end its life, and either its elements will go into landfill or it'll be a ruin. There's no sense of, well, at the end of its life, what else could this building become? And yet, the example of the birds building their nests with these spikes is that there are many different ways in which we can imagine the urban and reimagine the urban environment and imagine second and even third lives for the places in which we live and the buildings that we occupy. A good example of this here in Edinburgh is Pianodrome. I don't know if anyone's come across Pianodrome before. It's a performance space currently in the north of Edinburgh in Granton. It's constructed, you can see it's a kind of amphitheatre kind of arrangement. It's constructed entirely from old unwanted pianos, right down to the nails. The stairs are made from piano lids. The backs of these stands are made from old soundboards. And the wonderful thing about it is that they kept the harps and the strings inside. So whenever anyone performs in the middle of this space, the whole thing resonates like a giant instrument. It is truly extraordinary, and I strongly recommend that you all look it up. They do performances, I don't think it's all year round, but there's definitely a kind of season where they do a weekly performance. It's definitely worth going to. It's a wonderful example of exaptive design in action. You take something that nobody wanted anymore. Edinburgh is full of upright pianos nobody wants, and they just go into landfill. And they took them and they made an extraordinary and unique performance space out of them. The construction industry globally accounts for 40% of carbon emissions. It's a hugely wasteful and, in that sense, destructive industry. And yet, of course, we all need places to live and to work and hospitals and schools. So surely what we need to do is think about how we use these materials better. Can we imagine a second life, a third life, an afterlife for the materials that we make? Can we design in such a way that we already forecast what for future uses for these materials could be. When I was writing the book, I was lucky enough to go to something called the Waste House in Brighton. It's in the University of Brighton forecourt, and it's a 2-story house built entirely from building and household waste. It is extraordinary. It's like kind of Hansel and Gretel go to the junkyard. It's really quite extraordinary. And it's an illustration both of how we really can do things that we haven't imagined before with things that we would otherwise have thrown away. But it also, I think, illustrates the difficulty of doing that when we don't plan for it. Okay, so moving on. I said that we'd also think about how we might rethink our relationship with time, which might seem like quite an elliptical, quite a abstract notion, but I think it does get to the very heart of our relationship with the natural world. And the term I wanted to introduce you to here is wild clocks. All life depends on coordination. Every creature has what's called a chronotype, an expression of time, a sense of when it is appropriate to migrate, to breed, to enter into hibernation, a rhythm that is distinct to it. One of the many wonderful scientists that I spoke to in writing Nature's Genius uses the term, she coined the term wild clocks to talk about this phenomenon, the chronotype of every living thing. And a wild clock consists of 3 interrelated elements. First of all, she has what Barbara calls body time, the fact that all living things have particular sensitivities, cells in their bodies that are sensitive to daylight or sensitive to temperature. And these conditions, the daylight, the temperature, and so on, are the second element. They're sometimes called Zeitgebers or time givers. They're conditions in the world that communicate to the animal it is time to leave, it is time to go into diapause, it's time to start bulking up because you're going to be migrating. But the final element is perhaps the most interesting. The final element in a wild clock is other living things. Other living things with their own body time, their own time givers, because other species are constantly watching one another. The scientific term for this is phenology, the study of the timing of biological events. And a great many biological events depend upon a coordination between different species. So in nature, time is made by the coordination of these 3 factors. I think it's something that we can be reminded of in ourselves, for example, when we feel jet lag. But for the most part, I would say, we kind of forget this. We kind of forget that time and coordination is a matter of being in relationship with the world around us because we are so dependent on the clock on the wall. Unfortunately, because of climate change in particular, many wild clocks are struggling to keep time, and it creates a problem that we can call a chronoclasm. This is a term coined by the science fiction writer John Wyndham, and it describes a moment when different orders of time clash. COVID was a chronoclasm, when the time of the virus collided with our everyday lives and completely upended how we did everything. Climate change is a chronoclasm. Climate change does not happen at the same rate everywhere. It's happening up to 3 times faster in the Arctic than it is anywhere else. Time is being thrown wildly out of joint. We all have seen how the leaves on the trees in Edinburgh are browning so much earlier this year because of heat stress. These are all expressions of a kind of chronoclasm of time being out of joint. And so for living things, time that was made together is falling out of sync. Light pollution can be a cause for creatures to lose touch with their time givers. Climate change is causing temporal misalignments between predators and prey, herbivores and plants or flowers, and pollinators. And for example, we have Greenland caribou who are experiencing a mismatch, a temporal mismatch between the time in which that they would historically have reproduced and raised their calves, and the fact that plant growth is accelerating in the Arctic. So the plants are emerging and they're growing before the calves do, depriving them of a vital food source. Now, all phenological relationships have to be adaptable. We're not talking about clockwork here. Some have a wide margin so they can cope with a degree of change. Others have a lot of phenotypic plasticity, which means they can adapt when they do things. They can adapt their breeding times or maybe develop a pattern of breeding multiple times a year. But other animals, other plants and their wild clocks are too finely calibrated to cope with the rate of change. And at this level, in this case, at the level of species and of ecosystems, we can see really significant impacts, particularly on migration and breeding. Again, quite a bleak situation, which I apologize for confronting you with, but it does lead us, I think importantly, into a new way to think about our relationship with the time that we make with other species. And the term that I find useful here is kinship time. This is a term coined by a Potawatomi scholar, an indigenous scholar called Kyle White. Kinship time means experiencing time through relationship with other beings. The time givers in this case are other living things rather than the clock on the wall. And it's about marking time according to the health or ill health, the thriving or the struggling of those species and their temporal relations. It's about expressing and recognizing our kinship with other species and making the health of those relationships the key factor in our sense of, is it the right time or not? Now, this is an idea that's common to many indigenous cultures, but I think it can be a great challenge to our dependence on clocks and calendars. One of the reasons I think that we're stuck in the old way of doing things that is so destructive and harmful is because we're bound up in election cycles. We're bound up in the time that we have made for ourselves that excludes the natural world. And I think we can do better. I think we can make time with nature in a way that can help all of us thrive. So kinship time is something that I found enacted when I visited the Future Library project in Oslo in 2021. I don't know if anyone's heard of Future Library. It's a 100-year artwork. It's a project. Each year, an author writes a piece, a novel, a story, a play that is donated to the library and will go unread until the year 2114. It's a gesture of commitment and hope to the future. It's of saying, we believe there'll still be readers, there'll still be libraries. It's a gesture of trust. The other part of the project is there is a grove of trees in a forest outside Oslo that's been planted that will, in 2114, be cut down and used to make the paper, to print the books. And when I went to visit, I was lucky enough to have a walk there with a plant biologist called Anna Victoria Volsness, who explained to me how the temporal alignments in this forest are changing and how they will go on to change. She said 100 years is not a long time in the life of a forest, but you could see wild boar arriving from Sweden as their range expands with the expanding temperature. You could see whole new kinds of trees arriving, beech trees, mixing up the assemblage, and it could bring new parasites. In many ways, that could be quite fundamental changes to the ecological relationships in this forest. And so the question for me became, how might the project change alongside the forest? Every year, the authors enter the forest, and there's a kind of ceremony where they hand over their piece of writing. The first one was Margaret Atwood, and they've had some wonderful writers since, David Mitchell, Carl Ove Knausgaard, wonderful, wonderful writers, all of whom are giving work that none of us will read, which is kind of good and bad, I guess. But to be conscious of doing this over 100 years, and to be conscious of the way that the forest itself is changing, is a way to rethink how we might mark time through the ritual as it develops. The Russian poet Osip Mandelstam said once, "What tense would you choose to live in? I want to live in the what ought to be. The what ought to be. And that's a wonderful phrase, I think, because it expresses a duality. It expresses both loss and hope. What ought to be, but is no longer, and what ought to be, and which we are bringing into being. Kinship time inhabits this tense. The focus of kinship time is what ought to be. And it's an experience of time in terms of the thriving of other living things. So Future Library offers us a kind of ceremony, an example of a ceremony of what ought to be, a ceremony that aligns us not with the time of politics and markets, but with the time of kinship. Ceremonies of what ought to be could help us embed kinship time in our social structures. They could bring past and future into alignment with our calamitous present in gestures of remembrance and renewal. So what other kinds of rituals could we devise to help us make time together with other species? Mindful of time, I apologize for going slightly over. I'm just going to very quickly take us through the last question I asked. How might thinking about the way that nature is evolving under human influence help us rethink conservation? This is this figure here is the Lion Man of Hollenstein Stadel. It was carved from a mammoth tusk around 40,000 years ago and reconstructed from fragments that were discovered in a cave in southern Germany in 1939. It's perhaps the earliest existing example, the earliest example we have of the human capacity to imagine a form that doesn't exist in nature. No one has the head and body of a cave lion and the legs and forearms of a human. It's not clear whether it's a man or a woman, or he typically is called the lion man. Obviously, such a creature doesn't exist, but this is the first, one of the earliest examples we have, certainly as a kind of physical sculpture of the human capacity to imagine how nature might be different. But now that we are such a potent technological scientific force, the Lion Man poses a question for us. Should we consciously intervene in the evolution of other species that might otherwise be lost? So many of the impacts we're having are, of course, they're collateral. We don't intend to blunt the shape of cliff swallows' wings. That's a byproduct of the fact that we've built so many roads and fast cars. Precision gene editing technology has made a world of reimagined species possible, however. We can intake DNA from one species that perhaps has the ability to resist drought or heat waves and introduce it to another. Plants could be edited to cope with drought. Microbes could be programmed to sense and consume ocean plastics. Coral reefs could be made to withstand heat waves. We're looking at the virtual extinction of tropical coral reefs around the world at some point in this century if we don't arrest the rate of global warming. So I think it's an important question we have to face. There are, of course, technical challenges here, and I don't want to get into those, but there are also ethical questions. Should we do this? Should we be messing with the fabric of life in this way? Perhaps another way to put it is that with close to 50,000 species at risk of extinction, how can we afford not to? I think if we are even going to contemplate this question, though, we need to think not just about can we, but how we would do so. That also matters. I had the great opportunity to learn some insights from Maori conservationists about what kind of ethical basis would be necessary if we were to contemplate intervening in the evolution of other species. Maori worldview rests on a complex and detailed system of knowledge and values called Maturanga. And at the heart of Maturanga is a particular concept, whakapapa. Whakapapa isn't a concept we have in our culture. There isn't a direct translation, but it's usually translated as genealogy. When somebody describes or accounts for their whakapapa. They're talking about their lineage, their heritage, right back to their earliest ancestors, even to the gods. And in fact, the Maori say that all living things, each species has its own whakapapa, its own genealogy. So genealogy is typically how non-Maori have been taught to understand whakapapa, but a particular Maori conservationist called Marcus Shadbolt told me that a better translation is taxonomy or classification. Whakapapa is a way of sorting the natural world, sorting the relationship between things. And he told me a story to illustrate this. Once upon a time, the kauri tree and the southern right whale were close, even brothers. The right whale lived on land at this time, and yet he had a longing for the ocean. And he said to the kauri tree, I need to go, I need to explore the world that's out there, I want to swim. And so they exchanged gifts. The whale gave the tree his scaly skin so that it became a kind of bark, a rough bark to protect the tree. And the tree gave the whale an oil that would kind of smooth his way gliding through the waters. And that, in Maori belief, establishes a kind of united, a common whakapapa between these two entities. Very sadly, kauri trees became afflicted by a devastating fungus about 20 or so years ago, and no cure has been found for it until some Maori conservationists began making a compound out of the bones of southern right whales. Southern right whales had been beaching themselves on the shores of Aotearoa, and the Maori said they were drawn to the plight of the kauri trees. I don't know if that's true, but they created this compound, and initial findings showed that it was the first successful treatment for the kauri dieback fungus. Now, scientific studies have yet to conclusively prove that this is the case, but I do think it holds a lesson for us. Marcus told me that if you were to say to a Maori, I want to take the genes from a country and the right whale. I want to take a gene from the right whale and put it in the tree because it will save the tree. They would have no problem with that because the sense of relation between those two living things is so closely bound up together. Now, to us, that might seem uncomfortable, like the creation of a kind of Frankenstein's monster, but to the Maori, seen through the lens of whakapapa, through the lens of relationality, it is no big deal. I'm not decided personally yet on whether we should intervene in the evolution of other living things. I feel the pressure is quite compelling, but the ethical questions are equally compelling. But what I do believe is that any intervention we do make in the evolution of other species has to be grounded in the deep and abiding sense of relationship that comes through whakapapa. The key question, I think, is not can we or should we, but rather would doing this draw tighter the threads that stitch us to the weave of the living world. I think I will stop there. Thank you very much for listening.
We've had a very stimulating talk covering all kinds of areas, and I'm sure it stimulated some questions. If you have a question, please raise your hand and direct it directly to David, and he will answer it for us. Here we go. Giving people time to think.
Absolutely. Well, thank you very much for a fascinating talk. I was interested in what you were saying about the culture of an Indigenous people as well, because I've been involved in that a little bit recently with Mi'kmaq and things in Canada. And there they are turning our concept, our anthropogenically centered concept of how we relate to nature on its head. And instead of, thinking about what nature can do for us, it's about what we can do for nature. But it tended not to actually completely disregard everything that's gone on in terms of our increasing knowledge in the West in particular. And there's this two-eyed concept, which I thought was really interesting. And it's certainly something which I'm trying to adopt I'm chair of the board of SAMS, the Marine Science Place, and our relationship with the ocean should be one which turns that on its head as well. And we're now going to have a trustee on the board. And I think that's a concept which we could adopt far more widely as we engage with nature in terms of all the issues that affect us in the world today. But your views would be particularly pertinent to this. Thank you very much indeed.
Oh, thank you. No, that sounds fantastic. Yeah, I think we indigenous worldviews, many indigenous worldviews, and I don't want to generalize too much here. But there are many indigenous cultures around the world that have not lost the sense that we in the West lost a long time ago of our reliance upon and inextricable connection to the natural world. I think the great lie that we've told ourselves is that of separateness, that we live on one side of a binary, that the rest of the natural world inhabit the opposite pole. That has led to so much destruction, so much damage, and we're still dealing with the legacies of that. Of course, this is not to say that we can do without the benefits, the insights of science, but I think you're right. I kind of an approach of consilience, of reconciling a mode of understanding the world that's based in story, but also relationship with a mode that's based in empirical observation gives a much richer and fuller a worldview, and one in which we're much more likely to survive and thrive than otherwise. Yeah, thank you.
Another question? Yes.
Hello.
We need the microphone.
Sorry, I noticed something in my garden. I've got lots of daffodils. In the borders, they're growing up, the grass, which is not the lawn, but the other bits of grass and stuff, they all grow up the way. If it goes in my lawn, it doesn't go up, it goes along. All the leaves are flat.
Yeah.
Same thing in my drive. If one comes up in the joints of the drive, it grows flat. The only one I've got that's growing in a crack, which is going up, is one which primula is growing up beside it, and it's going up as well.
There you go.
Just wondered if there's anything on that.
I mean, I don't know. I don't think I can offer any insight into what's going on there.
Up in the lawn. The grass is above the daffodil.
Right. Okay. I mean, all I can say to that is life often finds a way. I mean, this is what has been so wonderful for me in writing this book is learning about the tremendous capacity the natural world has to just do things differently. It's not to not be bound by how things have been done before, the shape that you inhabited or the behavior that you cultivated. And I just think there's so much we have to learn from that. You know,
You're transferring genes into different things. There's a big controversy in Australia particularly at the moment, and it's spreading out to America, that some of these COVID injections contain minute amount of foreign genes, and they appear to be causing cancer.
Right. I don't know anything about that, I'm afraid, and wouldn't like to speculate. Yeah.
Questions here?
Thank you very much. Some new concepts to me this evening, including plasticity
Yes.
and urban evolution. And I couldn't help but think about its application to humankind, and in particular, the sort of puzzling feature of higher than expected mortality in Glasgow, and particularly some parts in Glasgow, than in surrounding areas. And the theory that that is caused not by poverty, or not only by poverty and the sort of dietary things that brings, but by a quite rapid evolutionary adaptation to the stress that the individuals in these areas have experienced in their life perhaps just 2 lifetimes. Is there a link there?
I don't know about that specifically, but there's definitely there are many studies that demonstrate that living in modern cities is having an impact on, I mean, particularly on us physiologically. What are some of the examples? Well, the first kind of big change is the revolution in sanitation in the 19th century, which changes mortality, has a big impact on mortality rates. And it's actually been observed that in American cities, the kind of average body temperature dropped in the whole population by several degrees because there were so many fewer instances of infection. But the really big change after that has been the emergence of consumer society, and we're eating softer foods they're not like, they're very synthetic. They're not like foods in nature. It's having measurable differences on our physiognomy. The average kind of human jaw is narrower than it used to be, which is leading to more and more incidents of dental impaction. The technical term, if you like, for this is called the consumer phenotype, and it's been demonstrated that we are physiologically, in observable ways, distinct, not a different species, but distinct physiologically from people who lived 200, 500 years ago, and it's the influence of living in the urban environment that has done this. So I can't speak to the particular example of Glasgow, but there's a wonderful book called The Species That Changed Itself by Edwin Gale that goes into this in great detail.
Where do you see the agribusiness in all of this, with its genetically modified crops, its selective breeding of animals, even cloning of animals, and where does that fit in? Is it good or bad, do you think?
I think we know that agriculture, industrialized agriculture, is hugely responsible for carbon emissions as well as soil erosion. And there's many great problems in the way that we currently farm and feed ourselves. In terms of the role that synthetic biology might play in how we feed ourselves, I think I'd be very skeptical of anyone who said, let's go ahead and edit the genomes of cattle to be resistant to drought, if that simply meant we could carry on eating as much dairy and meat as we do and contributing to the loss of ecosystems and so on. I think that doesn't represent any kind of change in how we think about our relationship with the natural world. But if we were to intervene in the evolution of coral to make it more heat resistant, that would be conserving an environment, because coral, as well as a species, is also an environment for about 25% of life in the oceans. And we'd be doing a huge service to making the living ocean survive, if you like. So I don't mean to suggest that synthetic biology is going to be is going to okay, I'll start again. I'm very wary of any technology that we might introduce that simply allows us to carry on business as usual without any reflection on how our relationship, our understanding of that relationship to the natural world should change. And some aspects, some kinds of gene editing in domesticated species, I think, would fall into that category. So I'd be very wary. Is that answer? Maybe I haven't. Did I come at that question the wrong way around? Okay. Please.
Is it the case that maybe in some cases, say for instance, increasing crop yields or resistance to drought, it would be acceptable, but in others not? But we have in many ways been doing this for hundreds of years, but not with technological progress.
Yeah, well, I mean, absolutely right. You could say that we have been intentionally intervening in the evolution of many species through domestication. I would say that that is also has contributed to a rather unbalanced relationship with the natural world. You know, there are far more cattle in terms of biomass on the planet than almost any other living thing. I think all other living things put together, in fact, us accepted. So I think, you know, the future of feeding ourselves really is in regenerative agriculture. It's in forms of agroecology that look to sustain ecosystems as well as feed people, rather than ramp up yields, you know, through technological wizardry. Yeah.
Thank you. This is a more personal question. When I saw the title of your chair at Edinburgh, English Literature and Environment, I thought previously they had been effectively two different subjects. Could you explain how you marry them in your work?
Yeah, thank you. As I was saying to someone earlier, you know, the environment, the natural world, has been in literature from the beginning. It's just not something that we have made our focus or our priority. But you know, you can't have Shakespeare without the Forest of Arden. You can't have Lear without the Blasted Heath. Nature is there, and I think there's a great deal that we can learn both about the literature that I study with my students, and about our relationship with the natural world, if we sort of bring those two together. And the other side of that is that I think, I mean, this is easier for me to say, I think, coming from literary studies, but everything is a story, really. Every living thing is telling its story. Every environment is, you know, a multitude of stories, and it's actually quite, when you take that approach, it's quite straightforward to see how you might take an approach based in storytelling and narrative and so on, and link it with this other discipline. The final thing to say, of course, is that I think, you know, that we live in a time of multiple ecological crises, and I think we need to find as many different ways of talking about this as we can. And I believe that literature has a great deal to offer in that regard as well. Yeah.
Anybody from this side like to ask a question?
I think the biggest thing that's wrong is that we don't understand evolution. So if we try to interfere by gene editing and things, we're doing things that might have unforeseen consequences.
Yeah.
And one of my examples for this is that ADHD at the moment, which is a big problem, it appears that it may have been selected for way back in the hunter-gatherer time, because if you suffer from ADHD and you're not focused on one thing, but you're looking around all the time,
right,
then you're less likely to suffer predation.
Right. Okay.
But that was hunter-gatherers, and we still have people who are now suffering from ADHD when it's no longer an advantage. So
Yes.
there's absolutely no concept of how evolution is going to work in the future.
Yeah, and
we should be very, very careful in any editing that we do.
yeah, I think I agree. Absolutely, I agree. And it's by no means straightforward either. I mean, I think it's one thing to change a single gene. It's very different to create a whole new phenotype. And then you've got to think about what ecosystem, what environment is that edited animal going to engage in. It's a very, very technically formidable prospect. But as I said before, I think with any of these new technologies that we have to think, well, how should it change us if we were to use it? You know, every single tool we've invented, from the stone axe to the internet, has changed in some way what it meant to be human. But we haven't always reflected on that, and now we have.
We have to think about that extremely carefully.
Yes.
Before we take any.
Yeah. Yeah, and I think there is still a great deal of caution around this. I'm not particularly worried about a world of Frankenstein's monsters, but I totally agree we need to be careful.
my very first lecture on ecology as a student, and I came away thinking, this is so complicated. We have to be very careful about moving anything because we don't know the effect.
Yeah. Thank you.
Thank you very much for all the questions, but thanks most of all to David, who has, I think, challenged our minds, brought us some new language, and given us a lot to think about. He did mention deep time. He didn't mention future fossils. So that's something for everybody to go away. If you go have a look at his website, his work at Edinburgh University, you can see him involved. The BBC Sounds involved in an interview on an international front, and he's written several books that are extremely well reviewed and are readable. You can see he has a fantastic way with words, and his prose is excellent. It's often commended by reviewers. So it's been our privilege to have David along tonight, and we're going to give you a small gift which I'll hand in tomorrow, just to say thank you very much for coming. But let us show our appreciation with a round of applause. Thank you.